Welcome to Cadbench. In this video, we are going to see a demo session about CATIA. We will tell what we are covering in CATIA first. If you open mechanical design, there will be part design, assembly design, sheet metal design, wireframe surface design. If you want to give dimensions to manufacturing, we will give it by 2D, right? Drafting is used to convert a 3D into 2D. After completing design, we will see about kinematic to move a part mechanically. It will come under digital markup and there will be a module named as DMU kinematics. If you open CATIA, welcome screen will be there. If you want to design, just go to start, mechanical design and select part design. Here you can give name for parts. This is called as graphical area. This is called as menu bar. In menu bar, here commands are like save, print, explode, redo, undo commands will be there. If you want to open recent files, here you can see. Or just go to file and select open and search for location. We can see what kind of tools that we are going to use in a particular model in insert menu. Here XY plane is top plane, YZ is front plane and ZX is side plane. Choose a plane first and choose sketch. We can develop a 2D first to develop it as a 3D. This is profile tools. Here drawing commands will be there. Constraints are used to give dimensions and relations. Operations are used to give fillet and chamfer. Relimitations and transformations are used to create duplicates and trim. For example, drawing a rectangle and giving basic dimensions here. Here we need to ISO constrain the sketch by using dimensions and relations. Then after we need to go for 3D. First 3D tool is pad. Pad is used to convert a sketch in 3D. Here we can give thickness. Basic and advanced in this pad will be covered and all kind of sketch based feature will be covered also. Dress up features don't need any sketches. We can directly apply it on 3D. Transformation features are used to create duplicates and mirrors. Reference geometry is used to create duplicate and planes and then axes. Measuring tools is used to check unknown measurements and dynamic section is used to get a section view of a component. We can use rendering tools to get a realistic output of a designed part. Here we will teach how to apply materials and how to check a weight also. We will teach boolean operations also. For using boolean operations, you need to create a multi-body. By using insert and then part, you can create a multi-body and you can easily use boolean operations here. This is called a specification tree. Here, history of features used to create a part will be appeared. This is called as view toolbar. Here, we can use this for zoom in and zoom out and use this for pan and rotate. We can change display styles also. We will teach mouse shortcuts for zoom, pan, rotate also. Normal view is used to get a planar view of a selected face. We will teach how to use display styles. Next, assembly design. There are two types of approach, top down and bottom up. Assembly will called as product also. Here we can design some products in assembly that's called top down approach. If you just assemble designed parts in assembly area, it will be called as bottom up approach. Here we can insert a component by using existing component command. Select and insert which part you need to insert assemble first. And here we will teach how to arrest degrees of freedom by using constraint commands. Just click product and part body to design a new one in assembly. This is called as top down approach. Here we will use product structure tools also and will teach all kind of constraint tools to give mates and arrest unwanted movements. And we will teach annotation tools also. By using space analysis, we can check gaps and clashes between parts. Next, drafting. To convert a 3D into 2D for production drawing, drafting is useful. If part is open, we can directly go for drawing sheet. Here we can select if the sheet need to be empty or not, or with views or not. Here we can change sheet size and orientation also. We can choose first angle or third angle projection. We can select views and easily change the properties of a part and display style of a view. Here we can give dimensions by using dimensionings and we can get all kind of views by using this views toolbar. Here we can add GDNT symbols by using annotation. Add additional sheets by using this sheet command. We can get multiple sheets in a drawing file. Next one is sheet metal design. For sheet metal design, you need to go for start and go for mechanical design and just choose generative sheet metal design. To enable all sheet metal tools, you need to give parameters first. For giving parameters, just select sheet metal parameters and give basic parameters like sheet metal thickness. Then only all kind of sheet metal tools will be enabled to work. First, draw a sketch to develop a sheet metal. To get a base one, you need to go for wall first. In wall, you can give the thickness and you can change the direction also. Then after, you need to get the side edges. So means side walls. For that, you need to go for wall and edge command. Here, lot of advanced features in wall and edge will be covered. Then all kind of sheet metal tools will be covered also, like cutting and stamping also will be covered. In stamping, how to create a own stamping tool will be also teached. Transformation features also will be covered here. In roll walls, both kind of tools will be covered and explained. Next, surface-based tools. By using wireframe and surface design, we can create a surface modeling. Surface modeling is specifically used in automobile designs. Here, first surface-based tools will be taught to create some surfaces. Surface is an illusion. First of all, we need a 2D to create a surface, right? So just I am drawing a sketch here to change it as a surface. First, extrude tool in surface will be covered. It will convert a sketch lines into surface. We can give how much length it need to be, but we can't able to give thickness because there is no thickness in surfaces. To give thickness for the surface, you need to go for part design, and in that there will be surface based tools. Here you can easily give thickness, and there are lot of surface based tools will be there. Everything will be covered. You can easily convert a surface into solid. Here wireframe and transformation features, operation based features will be also taught. By the way, body in white concepts will be also taught, and advanced trim tool surface tools will be also covered. Because CATIA is mainly used in surface modeling to create outer bodies of an automobile part or else automobile vehicles. Next, kinematics. Just go for start and go for digital mark and select DMU kinematics. Here we can check the movements. We need to choose a product first. Here I am selecting an assembly product. It's an assembly, right? So there will be some constraints. By using joints, we will teach revolute joints, prismatic, screw jack, rack and pinion, etc. etc. Here in specification tree, we can check which mechanism is applied to this assembly. We can simulate this as a video also and play it as a video file like this. By using animation toolbars, we can easily save or generate an animation. If you have any other queries, kindly contact us and given below number or else visit us in cadbench.com. Thanks for watching this video.